In the next several videos, we'll be learning how to name compounds and how to write formulas. That's called nomenclature. And first, we'll start off by naming ionic compounds. So as a review, an ionic bond is an attraction between a positive ion, that's called a cation, and a negative ion, which is called an anion. So it's an attraction between a cation and an anion that results from the transfer of one or more electrons. And you remember that an ionic bond occurs between a metal and a nonmetal. Now I know I've kind of reviewed this quickly, but it's important for you to know these terms. These terms will come up the entire year. One way you can remember that a cation is positive is using this, little trick here. A cation is positive. Also, what I've done is I've replaced the T with a positive sign, indicating that, once again, the cation is positive. An anion, this is not what an anion stands for, but you can think about it standing for a negative ion. In fact, that's what an anion is. It's a negative ion. Okay, so here we go. Let's look at naming ionic compounds. You probably already know this. For example, you probably recognize this as sodium chloride. How did you know the name was sodium chloride? Well, you just probably knew it, but here's rules to help you out. The cation is named first. That would be the metal, sodium, and it's simply called by its name. The anion, that's going to be the nonmetal. That's going to have a negative charge, and that will be named second. It's called by its root name plus the suffix "ide." So notice that you're kind of changing the name of chlorine to chloride. So this is called sodium chloride. Same thing here. We'll name this element first and then this element second. Notice that the cation traditionally comes first and the anion comes second. So essentially you're providing the name of this element, which is strontium, and then you're looking at this element and then just adding the suffix "ide." So this is strontium and sulfur. So this would be called strontium sulfide. In this next example, we have lithium and oxygen. It does not matter how many lithium ions there are. There's two, but that's not relevant here when we provide the name. So the name of this is just lithium oxide. Same thing here. It doesn't matter that we have two iodines. It's simply called magnesium iodide. So these were fairly straightforward. Let's try a little practice with some more challenging ones. Some transition metals, you remember that transition metals are the metals that appear in the middle of the periodic table, form more than one type of cation. For example, we have copper plus 1 and copper plus 2. If this is the case, we have to use the anion, remember that's the negative one, the one that's written second, to determine the charge of the cation. And then the charge is written as a Roman numeral. For example, copper 1 and copper 2. So I've intentionally selected three words to underline here: transition metals, ion, and charge. So take a little bit of time to read this again and understand what all of these things are. Okay, here we go. This is copper chloride. But you'll notice that copper is a transition metal. And because copper is a transition metal, we don't necessarily know what the charge is. Is it copper 1? Is it copper 2? We don't know. So if you notice a transition metal, then that means we're going to have to use the anion, remember that's the thing that comes second, to determine the charge on copper. And then once we figure out the charge is going to be written as a Roman numeral. So using your periodic table, you know that chloride always has a charge of -1. So what would be the charge on copper if we want to ensure that copper chloride here is electrically neutral? What I mean by electrically neutral has the same number of positives and negatives. So they should cancel out. So here, copper has a charge of +1, and that cancels out the -1. So the name of this would be copper 1 chloride. Let's do it for this compound here. This is also a copper chloride. So once again, recognize copper as a transition metal. Because copper is a transition metal, we don't know the charge. So we have to use the anion to help us determine the charge. And the charge on chloride is always -1. However, we have 2 chlorides. So we have a total charge of -2. So that means copper has to be +2 to balance out that -2. So the name of this compound is copper 2 chloride. Now, here's where students oftentimes get tripped up. They look for shortcuts or easier ways to do this than what I'm describing. As far as I know, there is no easier way to do this. This is the best way to do this. So follow these exact rules. Now, what does the Roman numeral tell us again? Students often think that the Roman numeral tells us that there are 2 coppers. Well, how many coppers are here? You can clearly see there's just 1 copper. So what the Roman numeral tells us, remember, is the charge. You must commit that to memory. The Roman numeral here, like 1 and 2, that does not tell us how many coppers there are. It tells us the charge on copper. That's very important. And once again, how do you know when you have to report if an atom has a charge or not? Well, if it's a transition metal, then you have to say what the charge is. How do you figure out the charge? You're going to use the anion. So let's follow these steps. Copper sulfide. Well, copper is a transition metal, so we need to say the charge. Let's use the anion to help us. The anion is sulfide, which has a charge of -2. So copper must be +2. So the name of this compound is copper 2 sulfide. Okay, platinum's a transition metal, so we have to say the charge. Oxide has a charge of -2, and we have 2 oxides. So that's a total charge of -4. So platinum has to be +4. So this is platinum 4 oxide. Here's lead and bromine. Well, lead is of course a transition metal because it's found in the middle of your periodic table. Bromide always has a charge of -1, and we have 4 bromides. So that's a total of -4. So lead has to be +4. So the name of this is lead 4 bromide. Okay, let's do one more. You'll recognize iron as a transition metal. That means we need to say what the charge is. To help us figure out the charge, once again, we use the anion. And the anion here is oxide, which always has a charge of -2. But we have 3 oxides. So that's a total charge of -6. That means our positive charge has to be +6. But the convention here is that when we report the charge on iron, we're reporting what the charge is on just 1 iron. So if we have 2 irons and the total charge is +6, what does the charge on each one of those irons have to be? Oh, that's right. The charge on 1 iron will be +3. And because we have 2 irons, that's where we get a total positive charge of +6. But when we write the name, it should be written as iron 3 oxide.